Hi there, this is Jacob Nash Engineering Lessons, and this is Unit 2.1, Lesson 14 on Trusses, and this is Standard 2.1.6/7. I think it goes into 7 also. So, what are trusses? A truss is composed of members joined together at their joints. So, basically, it's just a structure that is composed of members, and we'll learn what those are, and they're joined together at joints. A simple truss is composed of triangles that don't lose their shape even when removed from supports. The triangle is the strongest shape, the McGilster once said, and it is. It's commonly used in buildings as we know it. If you know about that structure, that's a truss. Also, some bridges use it. It is a very strong shape, because if this middle line wasn't here, it could possibly collapse. That's why there needs to be two triangles. There are certain supports that are used for trusses, and there are two types that we'll talk about. A pin support has two dimensions and two reactions, so it's basically just a pin, and the symbol is a triangle, and basically it has a X and Y reaction force, and we'll talk about this more in Activity 2.1.7. A roller support has one dimension and one reaction, so that's the only difference between the two. This one is a roller, it has a circle, and also it only has a Y reaction force. And so there's only one reaction force for a roller, but two for pin support. So there are parts of a truss. There are members, joints, and supports. The blue is what the members are. So there's when we go down here to how many members, joints, and reaction forces, there are 5 members. This one, this one, this one, this one, and this one. There are 4 joints. 1, 2, 3, 4. And there are 2 supports, but it asked how many reaction forces there are. There are 2 with a pin support, so 2 here, and 1 with a roller, so 3 total reaction forces. So 5 members, 4 joints, and 3 supports. Static determinacy. Static determinacy is basically if a truss is statically determinate, it is a structure that can be mathematically solved. So basically, it is reliable and stable. But if it's not statically determinate, then it's unstable and could pose a threat. So engineers need to calculate and see if it's statically determinate so that they can know if the truss is usable. The equation that we can use is 2J equals M plus R. J equals the number of joints, M equals the number of members, and R equals the number of reaction forces. If you could handle this slide, then that's all you have to do. So, is this truss statically determinate? Well, let's solve. So there are 4 joints, 1, 2, 3, 4, 5 members, 1, 2, 3, 4, 5, and 4 reaction forces, because there are 2 pin supports and they both have 2 each. And that says 8 equals 9, which is not true. 8 does not equal 9. So, no, it is not statically determinate. This would be a terrible truss to use. But what could we change to it to make it statically determinate? Well, we could take away one of the members, this central one, and that would make it 4 plus 4 equals 8. But that would be a bad idea because, like I said, it wouldn't really even be a truss anymore if you took away this one. Instead, we can change the pin support to a roller, and that makes it the exact same as on this slide. so that now that it has 2 and then 1, so 3 total reaction forces, which would make 5 plus 3 equals 8. So that would make it statically determinate. That's actually it for this video, and you might say, oh, that's kind of short. Well, next one's going to be the longest and last 2.1 lesson. Lesson 15. And I mean, it may not be the longest lesson, but I think it might be because we're going to be solving a truss, meaning we're going to find all of the internal and external forces on it, and that takes a very long time, even if you know how to do it good. And especially explaining it will take a long time. So we're going to solve activity 2.1.7, and that it may not be the exact same, and I'm not doing 2.1.6, although that may be something you have to do, so I'm sorry I can't support you with that, but stay tuned for that lesson. Thank you for watching.